All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue learning about the Hugging Face Transformers library. More specifically, I should probably stop saying that we're gonna be learning about, because at this point we mainly just have to test out a bunch of different models. Um, okay, so that's what we're going to be doing. We're going to be testing out, I want to say, a bunch of different models, but like I don't know how big each of uh, each of these models is gonna be. So oh shit, we are dropping frames already. Okay, give me a second. Let me try to do something to mitigate this. Um, Hold on. There's a couple of things that I can do that would possibly help. Okay, I think we are good. Yes, we are hopefully good. Okay, so back to what I was saying. Yeah, I'm gonna see how many of these models I can actually test out, at least on stream. I can test them out all I want off stream, but on stream I'm gonna have to be mindful of how many of them I'm testing out, because the models have to be first downloaded and then they can be used. Now, after they've been downloaded once, actually, to be honest, once I download one of them once, I should be fine for a while, because a couple of these models that I'm going to be using, they are actually older models, which I don't think they're necessarily being updated all that much anymore. That doesn't make them useless, but I don't think they're necessarily being updated anymore. I can actually check that. Give me there's that clicking sound again. I can check that. Give me a second. For example, let me take a look at Distilbert and see what pops up. Wait, I spelled distill wrong, and it's still it showed, I spelled it as distly, and it actually showed me distly. Okay, so I'm looking for Distilbert base uncased. So let's open that up. And here, where do I see when the last time was that this was updated? Um, okay, so that's the data set. Oh, dude, I could look it up. I could look it up here, right? Yeah, I can do that. Where's the search thing? Here. All right. So, Distilbert. This is the specific one that I'm looking for. Right. So here, where do I check for when the last time this was updated? Um, so this is datasets used, and this is mentioning when the dataset was updated. Actually, this just occurred to me that I could probably read the model card to understand what exactly I could do with this model. Okay, this is from Distilbert specifically. Who am I supposed to be looking? Well, okay, downloads last month is this, so I think we are good. Oh, we could look at files and see if any of the files were updated recently, or whenever the last update was. So it seems like the last update was around a year ago, maybe. Which isn't, it's not necessarily a bad thing. I'm just, checking. And there's a safe tensors thing as well. Great, awesome. What does this do? Oh, this is displaying the entire thing. Okay, that's why it's slowed down. Holy shit. Okay, that's crazy. Uh Wait, give me a second. I had something open. Let me just also wait, what is Rust model? I'm curious about this. Distill Bert Rust underscore model. The Rust model.ot file. Okay, I like that it found exactly what I was talking about. File is the Distilbert model's weights formatted for use with the Rust Bert crate in the Rust programming language. I didn't know that was a thing. Okay, cool, cool. Rust model.ot file. This specific file found in Hugging Face model repos like so and so contains the model's parameters optimized for loading and inference within a Rust environment. The .ot extension likely refers to Open Tensor format or something similar used by underlying libraries. That's interesting. Hold on. I need to have a conversation with Gemini about this. Maybe I could do it in one of these conversations so like you guys would be able to see it as well. I think we are done with this convo about um what was it? What was it? What is dude, this clicking sound. I don't know. I keep noticing this clicking sound as I'm doing it, but I don't. Anyways, give me a second. I need to open up my chat in on my phone. Okay. All right. Right. So, uh I just copied that thing, but for the sake of being on the safe side, let me just do this and try to paste. We are good. Let me try to paste something else here. We are good there as well. Okay. Right. So I was looking the at one of the Distilbert models on HF and noticed rust underscore model dot ot. Explain this to me. Okay, in the meantime, what was I doing? Also, hold on just a second. Right. Okay. What was I doing? I think I was looking at the files of this. I think this is part of the message pack. I think this is the message pack format. So like the weights are being given in like multiple different formats, so you can use the weights in multiple different situations. Because there's message pack, there's safe tensors, there's PyTorch model.bin. I need to look into this as well because this is a .bin file. So I'm wondering if this is the entire model, which I'm not sure how you would be loading that into PyTorch and Python, unless you are doing unless it's a pickle file. Um, if it's not a pickle file, then it might just be a binary, as in just bytes. So the weights might be, but then yeah, no, hold on. I need to look into this as well. and see why this file is there. But then, yeah, you have this. You also have something for TensorFlow. I believe this is for TensorFlow. Then you have this one for the Rust version of the model. And you have model.safetensors, which I'm assuming is for basically anything that can load safe tensors, which is convenient. That's great. Oh, we got the answer. Rustmodel.ot is a file that contains the model's weights, similar to PyTorch underscore model.bin or tfmodel.h5. The key difference is that this file is specifically for for use with. Oh, this is for use with Candle. Okay, I didn't realize that. Yeah, okay, so they do have implementations of these various models that are implemented within the Hugging Face Transformers library. They do have implementations of these in Hugging Face Candle as well. Candle is um, it's a deep learning, let's say, inference framework uh, built in Rust by Hugging Face. So if you want something that's like, mostly Rust based and you don't want to come to the Python side, then you can try using that. A bunch of the models have been implemented there. Okay, so Rust model indicates that it is for a Rust based framework. .ot. What was the other thing saying? Hold on. No, this said Rustbert, not. Let me look up Rustbert. Rust native state-of-the-art NLP models for NLP models and pipelines. It's a port of Hugging Face's Transformers library using TorchRS or Onyx Runtime. Okay, all right. Okay. All right, so .ot, this is the file extension used by Candle, which stands for Open Tensors. It's a custom, simple, and oh, I didn't know this was also like specific to Candle. It's a custom, simple, and unsafe format for serializing tensors. In short, it allows you to run models like Distilbert natively in Rust using the Candle framework, which is often desirable for performance, safety, and creating lightweight standalone binaries. All right, okay. Hey, explain the PyTorch underscore model.bin thing. Also, I didn't know that the OT file wait, I need to change this to a lighter model. We can go for light. We don't need like too much information. Okay, good. Explain this. Oh, this is the older one. Right. Explain the PyTorch underscore model.bin thing to me. Also, I didn't realize that OT was for Candle specifically. Online, it was mentioned, or I should say, Google AI, which I'm talking to Google AI anyways, but okay, Google AI mentioned that it might be for a crate called Rustbert. What other questions did I have about this? Okay. Also, you mentioned that OT is a custom, what were the exact words? Custom, simple, and unsafe format. Isn't that bad? Though I'm wondering if in this case they meant unsafe as in um, unsafe, like Rust unsafe. Rust unsafe is basically when a bunch of like the borrow checker related rules and stuff, they won't be forced onto you. A bunch of different checks that the compiler would otherwise do in order to prevent you from writing certain types of code that could cause, runtime issues. The compiler is not going to stop you from doing that if you're doing that within an unsafe block, because whatever you are writing within an unsafe block, you're basically saying that all the code within this block, I know what I'm doing. Just let it happen. Don't stop it. Though I should see to what extent it's possible to, do that. Because for one thing, I don't think it's going to let me break the language rules, language syntax rules. I mean, I don't think it's going to let me go that far. But in terms of memory allocation, memory access, and stuff like that, yeah, I think it does give me a little more freedom. It's not going to be it's not going to be as strict. I should explore that though. I haven't really played around in unsafe within the unsafe environment a whole lot. Also, something that I noticed is, oh, okay, I like that this time the answer came fast. I guess I should use the light model and only stick to um, I think it's Pro 2.5 or whatever it was for more heavier tasks. If it's just regular conversation, which I'm pretty sure, like when I'm pretty sure that the information that I'm asking Gemini about it has already been trained on, then I can just use the light thing because it's a regular conversation. Gemini doesn't need to do like a whole Google search and stuff. Okay, you've hit on a few important points. PyTorch underscore model dot bin. The PyTorch model bin file is the standard way PyTorch models learn is the standard way PyTorch models learn parameters, which are weights and biases, are saved. When you download a model from Hugging Face that's intended for use with their PyTorch library, oh, this is when you're trying to use PyTorch specifically to run the model. Okay, this file contains the numerical values that define the model's learned behavior. You typically load this file using PyTorch's torch.load function. Okay, OT format and rustbird. Candle specific words. Actually, this word specifically is causing a problem. Candle specificity. That is wow. Okay, candle specificity. You are correct. The OT format is specific to Hugging Face's Candle framework. Candle is designed for high performance inference on resource constrained devices and is written entirely in Rust. Rustbird, while Rustbird is indeed another prominent Rust library for NLP, it often uses different serialization methods for its models. It might not directly use the OT format. It's possible Google AI mentioned Rustbird as a general example of Rust ML libraries, or it might have its own internal formats for weights. However, Candle's OT is a distinct format for its own ecosystem. Unsafe format, is it bad? Yes, unsafe in the context of data formats can be a concern, and it's good you asked. What unsafe what unsafe means here. When we say the OT format is unsafe, it means it doesn't include the robust security checks that that formats like safe tensors do. The primary risk is that if you load a model file from an untrusted source, it could potentially contain malicious data that exploits vulnerabilities in the deserialization process, leading to security issues or crashes. It's akin to loading raw, untrusted binary data without much validation. Why it's used. Candle uses OT because it's simple and fast for scenarios where you have a complete trust in the source of the model file. Example, you trained it yourself, or it's from a highly reputable internal source. The speed and simplicity of OT can be advantageous. Okay. The alternative, safe tensors, for broader use cases, especially when downloading models from public repos, safe tensors is the preferred way and safer format. Hugging Face and Candle also support safe tensors. That's good to know. Which is designed to prevent arbitrary code execution during loading while still being efficient. Okay, so I have a couple of questions here, which I'm going to note them down here and then copy it over. A couple of things. One, uh, you mentioned using PyTorch. No, what was exactly what was mentioned? You typically load this file when using PyTorch's .load function. No, that's not what I was looking for. With their PyTorch library. Okay. Mentioned you mentioned using an HF model with their PyTorch library. I don't fully understand what that means. Is there a difference between running a Dilbert model using HF transformers versus using HF transformers PyTorch? Also, is this some separate, I spelled separate wrong, separate version of PyTorch? Okay, my next question was, okay, you are correct that OpenTensor, so-and-so, so-and-so, so-and-so. Okay. Yes, unsafe in the context of data. Wait, okay, I should look into Candle once more, but specifically for running models, not for training models, and more specifically for running models that are supported by Candle already. Because I definitely want to try running some of those models on resource constrained devices. I want to see how far I can get with that. Because one method that I've seen people mentioning for running models on much more resource constrained devices is quantization, where you're essentially reducing the bit depth of the data within the weights. And I think there might be some changes being made to the model as well. I'm not sure, but definitely with the weights, you're reducing the bit depth. I need to see to what extent this is effective, and at what point does it start to negatively affect the model's performance. Well, in general, I also need to just learn about the concept of quantization, because so far that's all I know. It's you're making the weights precision much smaller, thereby making the weights themselves smaller, and because of that, you're able to load them onto resource constrained devices, and also the calculations that are taking place, they aren't as heavy as if you were using, the actual weights, the unquantized. I'm not sure what to call that, but yeah, the unquantized version of the weights. Um, I need to see what the performance would be like. Would it still be as accurate, or would it start to have false positives or stuff like that? What was my next question here? Oh, I think it was something relating to unsafe. Um, Hold on. It could potentially contain malicious data and data that exploits vulnerabilities and so on, so on, so. Okay, I don't understand how OT can contain malicious data. Isn't it just weights, or is it a pickle kind of situation where arbitrary code is also being exported? What what other? Okay, the alternative safe tensors for broader use cases, especially when downloading models from public repos. Safe tensors is a preferred so and so. Okay, I guess my last question here would be, when I'm using HFT, would I be able to specify? Actually, I think I can. Yeah, I think I can. There's a flag. I remember there's a flag that allows you to specify that you want a PT format. For what exactly it was, I don't remember, but the idea is that it returns a tensor. Otherwise, it's going to return some kind of uh, JSON object or something like that, which you then have to, deserialize or whatever. Actually, does it return JSON? No, it's not a JSON object. It's the data is returned as, I think, maybe some sort of dictionary. I don't remember exactly what type, but if you want it to be a tensor, you have to specify PT. So yeah, I guess here we can say safe tensor. Let's ask anyways. When Because in that case, what you're specifying the type for is for what what the data type is going to be of the output result. So you're specifying the data type of the output result, the output that's going to be returned to you, not the input that you're using to, you know, initialize the weights of the network. When I'm using HFT, would I be able to specify whether to use safe tensors or not? Also, I'm a bit confused on safe tensors and how I would be using them. Um, let's say I've built and trained an FCNN using PyTorch, and I want to be able to run this model in another project. Give me a second. In another project, how am I going about doing that? Does the model still, I'm pretty sure it still needs to be defined in the other project, still need to be redefined in the other project. I guess that's it. Just give me the info. No need to take any write actions. I don't know if this specific one is going to take any write actions, but just wanted to put that out there. Okay, now real quick. Are we good? I think we're good. Right. So I'm gonna give the now in the meantime, we are waiting. What else was I looking for here? I think I was looking at the repo, right? I'm guessing we're going to be using the safe tensors thing. Now we can go back here and read. Okay, this model is it? Oh wow, there's a good bit of information there. Okay, DistilBERT base model uncased. This model is this model is a distilled version of the BERT base model. It was introduced in so and so paper. The code for the distillation process can be found here. This model is uncased. It does not make a difference between English and English. Okay. Model description. DistilBERT is a transformers model, smaller and faster than BERT, which was pre-trained on the same corpus in a self-supervised fashion, using the BERT base model as a teacher. This means it was pre-trained on the raw texts only, with no humans labeling them in any way, which is why it can use a lot of publicly available data. I didn't get that. Hold on. This means it was pre-trained on the raw texts only, with no humans labeling them in any way, with an automatic process to generate inputs, uh, with with an automatic process to generate inputs and labels from those texts using the BERT model. Okay, more precisely, it was pre-trained with three objectives: distillation loss, mask. Oh, we were reading this yesterday. Okay. Intended uses and limitations. You can use the raw model for either masked language modeling or next sentence prediction, but it's mostly intended to be fine-tuned on a downstream task. See the Model Hub to look for fine-tuned versions on a task that interests you. At some point, we should look into fine-tuning some of the models that we get off of the hub. I feel like that would be interesting. We can test out the we can test out the different capabilities of these models, like, before fine tuning and after fine tuning, and that exact same model, maybe we could fine tune it on different types of data sets. We need to see what kinds of data sets are required for fine tuning purposes, and what is the fine tuning process like as well. Um, Okay, note that this model is primarily aimed at being fine-tuned on tasks that use the whole sentence, potentially masked, to make decisions such as sequence classification, token classification, or question answering. For tasks such as text generation, you should look at model like GPT-2. How to use. You can use this model directly with a pipeline for masked language modeling. Okay. Um, Unmasker. Okay, okay. Wait, I need to understand all of this, like what's going on here exactly. I need to copy this and paste it into Gemini and ask it to explain the whole thing to me. Here's how to use this model to get the features of a given text in PyTorch. Just a second. Okay. Then in TensorFlow, okay, limitations and bias. If the training data used for this model could be characterized as fairly neutral, this model can have biased predictions. It also inherits some of the bias of its teacher model. Okay. Oh, hold on. I think I'm getting it. So, okay, what we are looking at here is, um, I guess here they are trying to show the bias. That's why they made it racial. So here they were like, the white woman worked as so and so, the black woman worked as so and so. So yeah, okay, the bias will also affect all fine-tuned versions of this model. Okay, going back to this now, like once I saw a pattern here, then I understood maybe this is giving us multiple options and it's also giving a score. So that's the probability of what it thinks is the most likely one. So let's go up to this one, which says, hello, I'm a mask. And I'm guessing the mask is what it's supposed to predict. And the prediction is here. So I'm a mask model. Mask is what's being predicted, and that's going to be mentioned in the token string. So that's the token that's being predicted. I need to look into the CLS and SEP. SEP, I'm guessing, is separator. I'm not sure what CLS is. Maybe clear line kind of thing. Because I remember templates being a thing when we were looking into the. I think it was when we were learning the small LM course, or there was some kind of fine tuning related course. There was a course that went into supervised learning or semi-supervised learning, and then also fine tuning. We never really finished that course. We didn't. I mean, we did do like one or two chapters of it, and like each chapter was divided into multiple sub chapters. So we got like a good bit of information. One of the things that I do remember learning from that is the concept of templates. And each model has a separate template that it follows. Maybe there's like a standardized format, um, or a standard template that a bunch of people have agreed to follow, but like you do tend to have different templates and different templates being used in different models, and the tokenizer very closely follows that template. So the tokenizer has to be trained to actually follow that template, and I think not just output the well, depends on whether it's encoding the tokens, or as in encoding data into tokens, or if it's decoding tokens into data. But basically the idea is that like it does follow this sort of template format, um, to show the LLM the conversation that's taking place. That's kind of how the LLM knows, or whatever model is processing the thing. That's how it knows that, hey, this message is from so and so, that message is from so and so on and so forth. I hope we go into templates again. I'm pretty sure we're gonna go into it with the LLM course. Okay, so looking at the the different scores here, it seems like the highest score was given to role model. Yeah. Okay. Let's read let's read this answer. Okay, let's break down your questions. Hugging Face Transformers versus Hugging Face Transformers with PyTorch. Unified interface. Hugging Face's Transformers library is designed to be a unified API for working with state-of-the-art NLP models. It provides a consistent way to load, use, and train models like Distilbert, regardless of the underlying framework. Framework backends. The Transformers library supports multiple deep learning frameworks, primarily PyTorch, TensorFlow, and JAX. When you use a model with HF Transformers and PyTorch, you are using the Transformers library's implementation of the model, and that implementation is written using PyTorch's API and tensors. Okay, so the model has been defined in the library, but using PyTorch's API. So they're using nn.module and whatever comes under that, or whatever comes under NN in general, I guess. Give me a second. Let me take a sip of my energy drink and hydrate a bit because I am yawning. Though I'm wondering if it's because I'm in like a closed space. So I'm wondering if it's like an airflow issue. Yeah, hold on. Let me turn on the AC and see if it helps a little bit. Okay. All right. So, wait, this is interesting. I didn't know that they have like a dedicated Distilbert tokenizer. I should okay, I have a question about this. I don't think I should do it using Gemini CLI. I think I'll um, open up a new instance here. Yeah. All right. I'm currently actually okay. For a bit of context, I'm currently learning HF transformers. I'm also learning deep learning using PyTorch. So far, I've only gotten to FCNNs. I'm yet to, this is the same story that I repeat over and over again. I'm yet to explore CNN, RNN, and Transformer, uh, but I'll get to them soon enough. That being said, a lot of things surrounding Transformers and Transformer based architectures is kind of lost on me. Now, I know that in HFT, I can use pipeline to load a specific Distilbert, a specific model like Distilbert. Hold on, what's the exact name here? Distilbert base uncased. But something that I noticed, oh wait, I, oh, accidentally hit Control I instead of Shift I. Give me a second. Let me actually, if I hit Control I again, is that going to close it? I don't think it does. Okay, does Control I open it again? Control Shift I? Oh, it's Control Shift I, and that does open and close it. Okay. Right. Oh, and I'm also aware that there is something called auto tokenizer and auto model. But something that I noticed in the Distilbert base uncased model card is that they are is that you can also use Distilbert tokenizer and Distilbert model. See, this is interesting because I feel like, okay, wait. I'm a bit lost here, so I'm gonna need you to explain a bunch of these things to me and how they all connect. I'm just gonna pretend like I don't know anything, and Gemini is just gonna teach me everything from scratch. That'll just be so much easier than me asking for like specific knowledge. And how they all wait, explain a bunch of these things to me and explain how they all connect together. Um, Distilbert, Bert, tokenizer. I'm just going to throw in a bunch of stuff. Tokenizer, model, auto tokenizer, auto model, Distilbert tokenizer, Distilbert model. What else? Is there something more I need to throw in there? I think I'm good. How is all this working exactly? And well, I was going to ask, where does pipeline fit into all of this? Pipeline doesn't fit into all of this. Pipeline is more of the high level way of using this. So I don't know if I should even bother asking that question. But yeah, okay. Um, I was gonna do something before asking this question, right? Or after asking this question. I don't remember what it was. What was I gonna look at? I think I was about to say that, okay, so I know that BERT is an architecture, and just like BERT, there are a couple of other architectures, and these architectures are transformer-based architectures. Um, and where was it? Oh, yeah. So for each of these architectures, there seem to be, like at least for the more widely used architectures, like where you have a specific type of architecture that a bunch of different models are based off of. they'll create like a separate namespace for it. So like Distilbert apparently has like a bunch of different models, and that is why you have like a dedicated section for it. I'm sure just like Distilbert, there's probably a couple of others as well. Like, okay, we can take a look at IntelliSense. We can take a look at the list through IntelliSense is what I mean. So from transformers, okay, let's open up. Where is my project? Here. So let's open this up. Okay. Um, pi01.py and save that. So the file is there. Okay. Right. So import transformers. I love how fast this is, dude. Holy shit. Okay. So from transformers, I love that as soon as I compliment it, it's just like, okay, now I'm gonna take some time. Okay, from transformers. Well, I guess to be fair, there could be like a long list of stuff, right? So that, yeah, there you go. That's probably why. From transformers import. No, hold on. Import transformers. Right. Okay. From transformers import. Yeah, that's not giving me anything. Shit. I don't think. Wait, can we or can we not? Yeah, we can. Why was it being difficult at first? Okay, all right, sure, whatever. Um, model. No, that's gonna show starting of model. Is there a way that I can? No, that's not gonna work. Okay, let's look. Distill Bert. Yeah, so you have a couple of different ones here. So you have Distill Bert, um, just Distill Bert model. Then you have Distill Bert for masked LM. There might be one for casual LM as well. Maybe, I don't know if you can actually have casual convos with this, but token classification, sequence classification, question answering. This is what I'm talking about. Like you, if we search for different architectures, then we're gonna find a bunch of like hidden gems. Like I don't know which one else should I don't know. Is Llama gonna have something? Yeah, Llama has a bunch. Right? Llama is an architecture that, from what I understand, was worked on by Meta. Essentially, it's Facebook's creation, and based on Llama, you have a bunch of like different models. You also have different Llama architectures. You have Llama. This says Llama 4. You have the original Llama, Llama 2, Llama 3. I don't know if those are implemented or not. But okay, let's see if Llama 2 is a thing. Llama 2 is not a thing. It's directly Llama 4. Maybe they're just going with whatever the latest one is. Maybe going with the older one doesn't really have much uh, use for them. Or it's also possible that maybe I don't know. I don't know if, because I was about to say that it's also possible that maybe legally they're not allowed to, but like I don't know. Those were actually. Oh, there is also the fact that yeah, Llama initially, the very first Llama that had come out, I do remember this because back then I had done research on this, and I was super excited to see that, hey, Facebook is releasing, this open source model. It was open source, but they weren't just giving out the weights. Um, you had to like, you didn't have to pay them. It was still open source. You would get it for free, but you would have to fill out some sort of form, and then they would hand it to you. And then it was, I think, a similar situation with Llama 2, but you had a slightly more permissive license. And then I think with Llama 3, they just let go of all of the stuff and they were like, okay, you can use it for commercial stuff as well. Or maybe that was introduced with Llama 4. I don't remember. I might be mixing up the details, but yeah, I need to look at the list here and see this is wild because this didn't give me what I was looking for, but then when I actually searched, okay, oh, actually, hold on. Import. Is this what I was missing? Previously, like earlier when I tried to do this, um, from transformers, import. No, I wasn't mistaken. It wasn't giving me the list at the time. Now, what if I add transformers here and then try? So import, and then we get it. Okay, that might have been the issue. Yeah, I forget the namespace rules in Python um, often actually because I don't have to do this often. Um, yeah, yeah. Anyways, by the way, dude, yesterday, something I'd seen on TikTok, it all of a sudden got me interested in fractals, and since I basically spent the entire day yesterday, after stream at least, learning about fractals and what exactly they do. I did end up getting distracted with the concept of complex numbers, and then I spent a couple of hours just trying to understand that whole thing, the whole idea behind complex numbers. I've kind of gotten it, but not really. Like I kind of understood it, but then I was still having some trouble wrapping my head around it, and I'm trying to be better about recognizing when a certain bit of research is eating up a lot of my time. Um, and this was eating up a lot of my time. So I recognized that and I was like, okay. So the reason I was looking into complex numbers was because Gemini had told me that a bunch of at least the initial fractal sets, like the fractal algorithms, like Mandelbrot sets, for example, they can be implemented very easily in like one or two lines if you are using complex numbers. However, and this is the part like I didn't really ask this until much later after I had spent hours trying to understand complex numbers. And it's a really interesting concept. I'm gonna mention that. Like the concept of complex numbers is really interesting. I've only kind of understood it. I haven't fully understood it because I need to be able to like visualize it and also understand how the different operations in complex numbers are working. Complex numbers tend to follow certain rules. It's not as simple as Cartesian coordinates, which is like x and y. They tend to have specific rules. Those rules kind of make it so these numbers can be used in more complex calculations. And their operations can also be used in more complex calculations to make the calculations more concise. But you have to understand the concept of complex numbers itself. So I was like, okay, after giving up on complex numbers, I learned whatever I learned about complex numbers. It's great. Like up to whatever knowledge I did gain, that's great. However, I don't want to spend too much time on that concept. So I was like, I asked Gemini that, hey, see, is it necessary for me to learn complex numbers in order to be able to implement fractals? Because my whole thing was not to learn complex numbers, it was to learn about fractals and then later on implement them into Nano, for my creative coding purposes. So do I have to use complex numbers, or can I use real numbers? Because complex numbers, like I mentioned before, they follow different rules. They actually have a certain separate set of rules that govern how their calculations work. They don't work like your regular numbers. Um, why was I saying that? Anyways, I was asking Gemini that do I really need to, you know, get into complex numbers, or can I use regular numbers? Can I use real numbers to implement these calculations? The good news is, yeah, I can implement them using just real numbers. Complex numbers are just a more concise way of doing it, but if you're okay with a little verbosity, then you know, real numbers are the way to go. And so I'm gonna do it using real numbers because I'm having a little trouble wrapping my head around complex numbers, and I don't want to spend too much time learning complex numbers now because I already have a long list of things that I need to be learning. I don't have the time for that. It's crazy to think that I've got a long backlog of things to study that I actually don't have the time to study more stuff. I need to actively pick and choose, filter out what I really need to be focusing my time on right now. That's crazy. I will say this I will say this though. It's been a good start to 2026 so far. Not to, jinx it or anything. Um, but it's been a good start so far. And I've been doing a bunch of research, getting into. Ooh, I was asking Gemini about this thing. I just remembered that. Okay, yeah, yeah. I just remembered um, components and this and this and this. Yeah. Okay. Anyways, it's been a good start to 2026. I've been getting a whole bunch of research in. I have a better idea of what direction I want to take my research and my work and stuff in. I'm definitely getting getting better at streaming. The end of the last year alone, I was streaming a lot more often, and I'm hoping to stream a lot more often now. And now that I'm building this auto clipping tool, I'm hoping that I will be able to also, post more often, have more have more content to post on social media. I'm also considering maybe making the prompts for some of those NLP models a little more customizable. Like maybe I could set up some UI to some UI elements to allow the user to enter prompts and customize exactly what kind of content the model is supposed to be trying to clip, if that makes sense. Because anyways, I'm gonna have to give custom prompts, even with like the more what do I even call them? I don't want to call them like lesser abled models. They're the more basic functionality models. The Because I'm not using LLMs in all of these cases, right? I'm using like models that are for specific functionality, especially because they're going to be much lighter. I'm not looking to have an entire conversation with the thing. I'm just looking for very specific things, very specific, um, I'm looking for very specific type of functionality from them. So using these specialized models, it'll be much more efficient performance wise because I'm going to be able to run this locally, hopefully a lot more easier. And who knows, maybe what I'm trying to build, who knows, maybe the models might end up being small enough that even my mid-range machine is able to run the model, meaning people would be able to run this locally without ever having to touch the cloud, and other people would be able to use this to generate clips for themselves. Yeah, dude. I'm excited for this. I'm definitely excited for this. I think I'll work on this in like, incremental stages. Like I have to sit down and set up a workflow. I need to first prototype each of the stages that Gemini suggested, each of the activities that Gemini suggested that I do in order to produce the final product. I have to prototype each of these stages and then see what can be optimized in them, see what I need to change in them, and I forgot where I was going with this. Well, yeah, I need to either way, I need to prototype each of these, and when I am prototyping them, I guess I'll also find out how well they are able to run, as in run locally. Well, let me read this thing that Gemini said. Okay, it's completely normal to feel a bit lost in the woods when transitioning from feed-forward neural networks to the Transformers ecosystem. The Hugging Face library is designed to be flexible, but that flexibility means that there are often three different ways to do the exact same thing. True, true. One example is the pipeline versus explicit tokenizer and explicit model, or rather, I should say, the pipeline versus auto tokenizer and auto model method. Like both of these methods can accomplish the same thing, but there are different ways to go about doing things. They don't use the exact same method. They can give you the exact same result, the exact same outcome. It's just that one gives you ease of use and the other gives you customizability, if you need it, that is. Okay, think of the HF library as a tiered system. Here's a breakdown of how these components connect. The model architecture, BERT versus DistilBERT. Before looking at the code, you need to know what the blueprints are. BERT, bidirectional encoder representations from transformers. This is the gold standard model that changed NLP. It is very powerful, but also quite large and slow to run. DistilBERT, this is a smaller, faster, cheaper version of BERT. It was created using a process called distillation, hence the name. It keeps about 95% of BERT's performance, but is 40% smaller and 60% faster. That's still wild to me that it's able to keep 95% of its performance. Also, speaking of performance, I feel like testing models is something I'm gonna have to eventually look into. More specifically, benchmarking models, because I see these benchmarking scores for various types of models, especially LLMs or even like multimodal LLMs. I see benchmarking scores, but then I'm kind of lost on exactly what it's measuring. It looks great for the sake of, presenting a score that, oh yeah, this model scored higher than these 10, 20 other models, but like what exactly was being measured there? That's what I need to understand. Because I feel like it's a little more than just token count that's being measured. I feel like it's a little more sophisticated when you're trying to measure the performance of something. It's a little more sophisticated than just token count. The components, tokenizer versus model. In any transformer workflow, you always have two distinct parts working together in a pipeline, the tokenizer and the model. The tokenizer. Computers don't understand words, they understand numbers. The tokenizer takes your raw text, example hello world, and chops it into tokens, subwords, then converts those into IDs, numbers. Analogy, the tokenizer is a translator who turns English into a secret numeric code. Then the model. This is the actual neural network, the weights and layers. It takes it takes the numbers from the tokenizer and performs the heavy math to understand the context or make a prediction. This is the actual neural network. So this is where the layers are implemented, and it mentions the weights and layers, But then the weights are being loaded separately, aren't they? I guess it'll get to that part. Analogy: the model is the brain that processes the secret code to define meaning. Okay, implementation: specific classes versus auto classes. This is where you notice the difference between Distilbert model and auto model. Specific classes, the manual way. When you use Distilbert tokenizer and Distilbert model, you are being explicit. You are telling Python exactly which architecture to load. Pros, very clear. You know exactly what class you are using. Cons, if you decide to switch from Distilbert to Robert, oh no, Roberta, or Albert, I need to, okay, I remember Roberta being mentioned. Maybe Albert was mentioned as well, but like I need to look into both of these again. Now I understand what Distilbert does. I need to look into Roberta and Albert. You have to find and replace all your class names in the code. Auto classes, the smart way. Auto tokenizer and auto model are wrappers. They're designed so that only no words. They are designed so that you only have to provide the model name, like Distilbert so and so so and so, and the library guesses the correct class for you. How it works: HF looks at a config file inside the model folder. There, okay, yeah, there was a config file, right? Let's take a look at Distilbert's config file. I don't know if the information is like easily human readable, or even if it is human readable, I don't know if it's in a format that I'm gonna understand. There's a config.json and there's a tokenizer config. There's also a tokenizer.json. Let's take a look at config.json. Okay, activation, GELU, architecture, Distilbert for masked LM. Model type, Distilbert. Dude, okay, I need to, well, a lot of this is words. A lot of this is transformers related. A lot of these, terms. So, in order to understand this, I feel like I'm gonna need to learn how to create transformer-based neural networks. The thing is, I don't want to rush into it. I want to take my time, and well, I don't want to take my time. I don't want to skip. Let me say that I don't want to skip um, convolutional neural networks and recurrent neural networks, and then directly jump to transformer-based neural networks. I want to do CNN first, then RNN, and then transformer. But I'm taking way too long on just FCNN, as in the feed forward neural network. I'm taking way too long on that I'm not getting a chance to reach the other two. Something else that I could do. I could jump. I could do it as a need-based thing. So based on my requirement, I will learn the specific architecture, because these are not mutually linked together. But from what I understand, um, it's sort of like a mix and match kind of situation. When you're constructing your final network, you kind of combine these architectures in various ways. You don't always just use one architecture. A good example is with an image classification model using a convolutional neural network, a lot of times at the end, you're going to have one feed forward neural network to do the classification for you. But it's doing that classification um, based on the data that has been very heavily processed by this very complex convolutional neural network, beforehand. Um, but like the end step is still a feed forward neural network. Does that mean that this is just a feed forward neural network? No. Is it just a convolutional neural network? No. It's a neural network that's using these multiple neural network architectures to build a neural network. Yeah. Anyways, right. How it works. HF looks at a config file inside the model folder. If it sees Distilbert in the config, Auto model automatically, yeah, it does mention here model type Distilbert. Um, yeah, auto model automatically creates a Distilbert model instance behind the scenes. Pros, you can change your model by simply changing a string. It makes your model, it makes your code model agnostic. And they have not mentioned any cons of this. Okay, how they all connect. Well, yeah, at this point I get it. At this point I understand. Then the pipeline shortcut. The pipeline is the highest level of abstraction. Yep. Okay, so I already kind of guessed that. Um, when you call pipeline sentiment analysis model so and so, it does all of this for you. It calls auto tokenizer to load the Distilbert tokenizer. It calls auto model for sequence classification to load the Distilbert weights, and it feeds the text through both and gives you a human readable result. Just a second, just a second. Doing something here. Okay, right. Okay, what was the next thing? You know what I'm gonna do? Okay. Uh, all right. So I looked at the config file for Distilbert base uncased. I actually want to start another conversation. Hold on. I've had this conversation with Gemini a couple of times now at this point, but like I'm gonna have the conversation again. No, don't do that. Don't do that here. Um, yeah, do it here. Okay, so yeah, I can pull the context from the other conversation and drop it in here. Dude, I wish I had more computing power. Holy shit. For now, I need to rely heavily on Google Gemini and um, doing stuff through the web UI is incredibly fast, but I have to do stuff through the web UI. Doing stuff through the CLI is slower and extremely limited because I'm not paying for it. Like I'm not complaining about that. That's just the way that it is, and that's fine. But yeah. Oh, you know what I could do? Gemini CLI is for this purpose, right? Gemini CLI. I just said this purpose as if everyone knows what I'm talking about. No, Gemini CLI is Gemini CLI. It's used for um, a bunch of like code assist kind of stuff, and you can also have regular conversations with it. You can also get it to do various like automated tasks for you and stuff like that. Great, awesome, right? But it's limited to three models. It's limited to Flashlight, Flash, and Pro. I think Pro. Hold on, let me. I can show the list. Where is it? Yeah. So if you look here, there's three choices: Gemini 2.5 Flash Lite, Gemini 2.5 Flash, and Gemini 2.5 Pro. Um, there are other models that you can use through the Gemini API. You just can't use them through Gemini CLI as far as I've seen. you can use them through the API. You have access to them through the API, and you have an insane amount of like token, an insane amount of token count and requests per day, and like a bunch of different things. Like you're given a lot more. There's a lot more. What's the word I should use here? It basically gives you a lot more for free. But those models are not. They're not as advanced and sophisticated as these, but they're still decent. You can still use them, and it's not like they're bad. They're still they can still very much be used for a bunch of different things, especially if you're asking it questions about data that you know for sure it has been trained on. Um, then yeah, you can use it for that purpose. You can have a conversation with it for that purpose. So what I'm thinking is maybe I could try writing my own application. It's going to have to be Python based though, because the Gemini SDK is Python based, meaning um, I would have to find a decent way to handle handle the output for Gemini for the Gemini API. Actually, also handle the input, because there's a certain way that you have to go about, you know, giving the input and getting the output. Unless I want to like start creating the, you know, requests myself manually, which I honestly don't want to do that, because that tends to get a little more messy than I want to be. Or rather, I just don't want to spend too much time, you know, messing around with that lower level stuff. I would prefer to use a library that already implements that functionality. The thing is, when it comes to something like this, I would be trying to use, because my current daily drivers are Python and Rust. I would be trying to use Python or Rust. Um, Gemini API or the Gemini SDK is implemented for Python. It's not implemented for Rust. So that's where we kind of have an issue. Something that I could do though is set up a sort of server in Python and then have the front end be made in Rust. Kind of ironic that I'm setting up the back end in Python and the front end in Rust. That seems like, you know, the complete opposite of what each one of them is supposed to be used for. But I'm kind of limited here because, okay, wait, let me see. Because I remember somebody was making a Gemini Rust crate, and they were making some good progress on it. There was also like a community being built around it, which I'm super happy about. Um, but yeah, I kind of like the idea of setting up a server where I can, and it's going to be like a small delay, if I'm being honest, because I'm not expecting immediate reply, right? Um, so the idea that I had was we would implement the server in Rust. No, we would implement the server in Python solely because the Gemini SDK is in Python. So we'll set up the server in Python. I'll see if there's a way to set up a REST API server. Actually, that's a good idea. I need to talk to Gemini about this and see what are my options. How should I go about setting up the design for such a thing? Um, because there has to be, like, my initial thing was going to be a very primitive approach. I send a I send a from the Rust front end. I send a message over WebSockets to the back end. That message contains some kind of command which says, "Oh, this is what the user wants to do, and this is the prompt." The Python server uh, will parse that message and then, you know, do whatever communication it needs to with the Gemini API, and then it's going to get the result back and then send it back to the Rust front end. And I don't think all of this should be any slower than Gemini CLI currently is for me. So like I would probably be dealing with the same amount of lag, if I'm being honest. And in this way, something that I could do, if I make this scalable, then something that I could do is I could have one server handling all of these different requests from multiple clients. That would be interesting. So the server would need to be able to handle multiple clients. Um, Hopefully, I'm able to make the front end super lightweight in Rust. That'll give me an excuse to use Ratatouille. So I'm not complaining about that. Oh, before I forget, dude, I was gonna ask something to I was gonna ask something to Gemini. And I was also gonna copy this. That being said, a lot of things surrounding transformers and transformers-based architecture are lost on me. Okay, okay. Now that's great and all. No, let's not say that. Now I did mention that I was planning on covering CNN, RNN, and Transformer, but with how often I'm seeing Transformer, I'm wondering if it would be okay to jump from FCNN to Transformer and then learn CNN and RNN when the need arises? Or would I be missing out on valuable knowledge by skipping? I think the answer would be yes for this. I would be missing out on valuable knowledge. Um, but my question is that valuable knowledge, does that valuable knowledge pertain to both CNN, RNN, and Transformer, or does that valuable knowledge only pertain to CNN, RNN, and then Transformer has its own valuable knowledge that pertains to it? I don't know how to ask that question though. Anyways, or would I be missing out on valuable knowledge by skipping CNN and RNN right now? It is perfectly fine and increasingly common to jump from FCNN MLPs directly to transformers. In the modern AI landscape, transformers have largely superseded RNNs and are even challenging CNNs in computer vision. However, skipping them entirely leaves small blind spots in your intuition. Here's a breakdown of what you gain by jumping ahead and what you might miss. Why jumping to transformers works. Transformers are actually much closer to FCNNs than they are to RNNs. A transformer block is essentially just a self-attention layer followed by an FCNN, often called a position-wise feed-forward network. Parallelism. Unlike RNNs, which process data one step at a time, transformers process the entire sequence at once, just like a very large, smart FCNN. The Hugging Face factor. The HF ecosystem is designed to be high level. You can successfully fine tune a BERT or GPT model using their trainer API with only a solid understanding of tensors and loss functions. What you miss by skipping RNNs. RNNs and LSTMs were the kings of sequences before 2017. While you don't need them to code a transformer, they teach you the vanishing gradient problem. RNNs suffer from this severely. Understanding why they fail helps you appreciate why transformers use residual connections and layer normalization. Okay, sequential bottleneck. RNNs must wait for the previous word to finish before processing the next. This explains why transformers were invented to fix the speed issue. Then hidden states. Concept of a memory or summary of a sequence is easier to visualize in an RNN first. What you miss by skipping CNNs. CNNs are the masters of spatial hierarchy. They teach you inductive bias. CNNs know that nearby pixels are related. Transformers know nothing at the start. They have to learn every relationship from scratch. Feature extraction. Understanding how a filter slides over an image to find edges is a fundamental deep learning concept that helps when you eventually look at vision transformers. Okay, my recommendation, the hybrid path, don't ignore CNNs/RNNs, but don't let them stall your progress. If you're excited about transformers, try this. Learn the attention concept. This is the bridge. If you understand attention, you understand the heart of the transformer. Skim the RNN why. Spend 30 minutes watching a video on why LSTMs were better than basic RNNs. You don't need to code them from scratch, just understand the intent. Okay, okay, that's a good idea. Dive into transformers. Go ahead and start your Hugging Face journey. When you see a term like residual connection or bottleneck, quickly look up how it was used in CNNs like ResNet, and you're good to go. Okay, cool, great. Okay, now what else was I gonna look for? Was there something I was? Oh yeah, I was talking about Gemini, right? Okay, okay. Gemini API reference. The Gemini API is organized around the following major endpoints: standard content generation, streaming content generation, live API, batch mode, embeddings, gen media, and platform APIs. Oh, dude, I don't want to do this. Well, you guys can't see what I'm seeing right now, but like I'm looking at that whole thing. Generally, when you're working with like bare bones APIs, as in when you're only working with the API, then how do I even say this? Generally, when you're building things from scratch to interact with a RESTful API, you would need to do a bunch of different things. The requests aren't usually as simple as a function call. You usually have to craft an HTTP request. Um, the HTTP request has specific headers containing specific information, including sometimes the authentication token. There's also the authentication part. You sometimes have to authenticate with the server depending on what auth flow you are using. There's all sorts of like these complexities that you have to take care of. So you have to handle the engineering of this library first. You have to build the library first, and then you can use the REST API. And that takes, dude, I've done that. I have done that before using TwitchLib. I purposely decided to try and implement some very basic functionality by myself, and that's how I knew that I don't want to do this all the time. It's great for the sake of learning. Like that's how I know that you need to create an HTTP request. You have to within that HTTP request, you have to craft the headers in a very specific way, and there's specific endpoints that you have to hit in order to I don't know, log in or request connecting to something or request information and stuff like that. That is how I know all this, but that is also how I know that I don't want to have to do that constantly. because it is a nightmare. Doing that unless you absolutely have to is a nightmare. So instead, what I would much rather do is create a REST server, not a Rust server, a REST server that actually, okay, it doesn't even have to be a REST server. I could still go with my old idea. I'm going to present this idea to Gemini and ask if there are better ways to go about doing what I'm trying to do. And if Gemini suggests that, oh, okay, you could use this library that is meant for implementing these specific types of servers, which are a little more than just a simple WebSocket server that processes stuff and makes the appropriate function calls and all. Um, if Gemini suggests that, okay, there's these other things that you can explore, then I'll explore it. Otherwise, I'll go with my original plan because my original plan seems like it can work out pretty well. Also, I can actually achieve multi-threading with Python in this specific instance because for every single Gemini instance that I launch, for every single Gemini Rust CLI instance that I launch, I can create a separate process within the Python server. So the Python server is going to be running in like a main thread, right? Its own main thread. But then each time there's a new Gemini CLI Rust instance that's launched, it's going to connect to the server, and then the server is going to it's going to create a new process to handle this, to basically handle this connection. So I guess something else I'll need to take into account there is that uh, I think it's going to be multiple servers running. Oh yeah, that might become a bit of an issue. Scaling it might become a bit of an issue, or maybe not. It might work out well. I don't know for sure. Yeah, I can't say for sure. I don't know. Yeah, yeah. Because there's different architectures that I can use for that, right? Dude, why am I looking into this right now? I don't need to look into this. Why am I looking into this? I've done this before and I wasted my time. Um, I don't need to do this. I do not need to do this. Holy shit. I need to focus on I need to focus on my other things that I currently have planned and that I have not yet done. I need to focus on all of these things. Okay, that being said, um, I think, oh, there's a follow. Um, Angel, Angel, hello. Welcome to the stream. Thank you for the follow. Sorry, I noticed that very late. Yeah, I actually wasn't looking at my like follow list thing. But yeah, thank you for the follow. Welcome to the stream. Uh, I'm just about to end right now. I'm um, I'm gonna look for somebody to raid. So give me a second here. Uh, okay, I don't know if this person's stream is, wait, study and work. Hey, you know what? I think, okay, I can't go to this person's stream. I can't go to that person's stream because there are locks in place or settings in place. Um, hold up. I'm still looking, still looking. Studying for back-end developing. Okay, there's another person doing co-working and studying. Let's see. Give me a second. All right. I think we'll go to this person's stream. Yeah, I think we'll go to this person's stream. They are doing some back-end development. Um, yeah. Okay. So that's gonna be it for today's stream. Um, and yeah, I'm happy with the progress that I've made. Pretty happy. I'm happy with the progress that we made today alone. Like there was a good bit of research that we did, and yeah, dude, there's still a bunch of research that I have to continue doing. I need to. There's way too many things going on. I need to make sure that I don't get like off track. Uh, so yeah, yeah, okay. I don't know where I'm going with this. So that's gonna be it for today's stream. Angel, thanks for the follow. Anyone else who might have been lurking in the stream, thanks for watching. And yeah, that'll be it for today. I hope you guys have a nice day, and I'll see you all next time. Peace.